Now, as we start topic 2 of chapter 2, we're going to look at equations of lines in more detail and also picking up on things we covered in an earlier course. We're going to take a look first at slope. Now, slope is a ratio of y units to x units, or rise units, that is vertical up or down, to run, which is your horizontal. And they give you a little background here. So there we see the line that we have made a graph of, and we're now looking at the ratio of changing y over x, and we're making a little right triangle here, where in a sense this is the hypotenuse between our points. So what would this side be, which is our changing in y? So we can start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This would be 13. And then counting this way, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, when we go down like this is in a negative direction, so we put a negative by the 13. And when we go to the right, that's a positive direction. So our slope here from this is a negative 13 over 9. And another thing about negative slope is that it starts high, and as you go to the right, the line goes down. Now we do have a formula for slope, which is written down here. We're using the lowercase letter m for slope, which is change in y over change in x. And you can use these coordinates to actually do it, where let's say this would be your sub 2's and this would be your sub 1's, and you feed it into the formula here. So this would be 6 minus a minus 7, and then this would be a negative 5 here. Minus is in the formula a 4. So this two negatives become a positive, and this is a negative 9. So here we get a positive 13 over a negative 9. Well, that's what we got. We got the negative in a different position. Now, if we started here and went this way, that would be a negative 9. And then if we went up, that would be a positive 13. So we can find slope by using a set of ordered pairs, or by counting the legs of our right triangle, where the vertical is the y change, the rise, and our horizontal is the run. And we see this here, and there's our slope. Again, the best place to put it, of course, is usually right by the division bar here. And make your division bars horizontal. So let's do this one. Our sub 2 is 4 minus 8, 5 minus a minus 6, which makes this a positive. So this will be a negative 4 over 11. And you'll have practice, and hopefully you remember this formula from earlier lessons. We often call this formula 3. In example 2, they're asking us to find the slope of a horizontal line, as we see here. Now we can take any values we want. Here they're taking these two, So it'll be a negative 5 minus a negative 5. Remember, this is going to become a plus here. And this is a plus also. And that becomes a 5. Now, students often, when they get this from their substitution into the slope formula, they'll say this is the slope. But this is incomplete. 0 divided by any number other than 0 is 0. So we're saying that the slope of a horizontal line, and you might remember this equation is y equals 1, 2, 3, 4, 5, a negative 5. This is the formula of a horizontal line, and the slope of all horizontal lines is 0. Now here's a vertical line. The formula of this vertical line is y, no, let's get this one right here, x equals 1, 2, 3, 4. And what will be the slope of this? Now when we put it into our formula, using these 2 points, we get this is a 3, and 4 minus 4 is 0. Now again, this is the calculation, but what is the value of this? And we say that any number other than 0 divided by 0 in our mathematical system is undefined. So from now on, the slope of any vertical line will be undefined. And there's a little summation of what we've just said. Now, repeating what we mentioned in an earlier lesson, that we have what is called the slope-intercept form, which we're designating as Formula 2, y equals mx plus b, where our m is the slope once we solve the equation for a positive y, and then b is our y-intercept. So the slope and the intercept give rise to this formula. And here we see the summation of it, and this should be in your notes. Now, some of the examples you might get on your math lab preparation is to write an equation in slope-intercept form if you know the slope and the y-intercept. So remember, the slope would be m, and they're saying the slope here is a negative 5/2, and the y-intercept they're saying is 7/2. And the formula they want you to put it in is y equals mx plus b. So you would say y equals, and you have the slope, a negative 5/2. You have to put the x in, and then our y-intercept plus 7/2. So very easy, as long as you are identifying what your slope and y-intercept are. Now in example 5, they say the equation of a horizontal line with its y-intercept is 3. Well, we said that was formula 5, y equals b. So we could think of it in terms of slope-intercept, where our slope is 0, so 0x is 0, and you just get y equals the y-intercept, which is 3. So here they're showing you where it's derived from. Now for example 6, we have two items to work on, we want to again mention what is Formula 1 that we're using as a reference, and that's this one here. This is what we call standard form. And when it's in standard form, it's hard to pick out what is our slope. So what we do is we solve it for the letter y, putting it in slope-intercept form. And then we can easily pick out our slope and our y-intercept if needed. So here is an example in standard form. So we want a positive y. So the easiest way, just bring that over, and that gives you 3y. 5x, transpose the 1, and now you're going to divide everything by 3. Here this cancels out, and if you want to write it this way now, y equals 5/3 x minus 1/3. So our slope is 5/3, and our y-intercept is a negative 1/3. Now here the y is positive, so we'll transpose the negative 9x to the other side, so we get 6y. A negative on this side becomes a positive 9x plus 2. And now we divide everything by 6. So we get y equals, simplifying this, 3/2 x plus 1/3. So our slope and our y-intercept. We're going to use this technique a little later on in this section. And a key would be, as I look at your blue sheets, to give you partial credit. Did you carefully find your slopes? And I'm a little jammed up here, but you want to write it out very neatly and orderly on your blue sheets so I can give you partial credit. And you'll see where this is used in a little while. Now, as we look at this picture here, you think we're dealing with some kind of roadside in Spain. Yeah, I've seen things like this before. Quiver of arrows. What are they showing us here? Well, they're showing us the difference in slope. That here, this line is the slope of 1. Now, as it gets steeper, it goes to this line, which is the slope of 3, and even more steep, the slope of 7. And here, this drops down. This is the slope of 1/2. They're showing it as 0.5. So, which line has the larger slope? Well, the 7, of course. And if we were to see them in slope-intercept form, where our y-intercept is 0, the origin, this is what these would look like. So they're giving us a little review here, and I'll help out by saying, if a line looks like that, that's positive slope. Starts low and goes up. So this is positive slope. Starts high and goes down, that's negative slope. Is a horizontal line, that's 0 slope. And is a vertical line, this is undefined slope. So a little summary. Now, for example 7, they want us to sketch a line using standard form and find the intercepts. Well, I always suggest for finding the intercepts using this special x and y intercept t-chart. where whatever value is here, this will be your y-intercept, and whatever value is here, that'll be your x-intercept. So if x is a 0, what will y be? Remember, this is a 0, so you divide both sides by 2, and you get 5/2, or 2.5. And if y is a 0, x equals 5. And then you're asked to sketch that. Well, your y-intercept is 2.5, so there's 1, 2, 3. So you're going to have a dot right there, and this is 5. 1, 2, 3, 4, 5. And you take your line tool, and it will be a graph like so. And we'll see that shortly. And there it is. Okay, now we're asked to do something again we did in an earlier course, and that is to find the slope of parallel and perpendicular lines. And for this, on our formula sheet, where we said if the slopes are the same, but the y-intercepts are different, the lines are parallel. And that makes sense. So here's the slope of one, there's the slope of the other. They would be the same, but your y-intercepts are different. These lines are parallel. And here, if we multiply the slope of one by the slope of the other, and the product is a -1, such as 1/3 times a -3/1, the negative reciprocal of this, the product is a -1, the lines are perpendicular. And this would be like, this is 1/3 this way, a positive 1/3, and then this would be a -3 this way. This would be a 1/3 this way. I drew them off a little bit. All right, there we go. We have something like that. The lines would intersect at a right angle. These lines are perpendicular. So the idea is, normally they're going to give us the formulas in standard form. How do we know what they are? Well, in both cases I mentioned before, you're going to solve for y and solve this equation for y. And then this is the work we want to see. You look right here and you say, these are the slopes are the same. The y-intercepts are different. These lines are parallel. All right, we'll move it up. And there they give us a very professional looking graph. And in example B, again, the equations are in sort of a form. This one's in standard form. This isn't in any. We're going to bring our 7 over to this side. Then this is in slope-intercept. We have to solve for a positive y. So when we do so, we get a positive 3. This is going to be a negative 1/3. We multiply them together. Our product is a -1. The lines are perpendicular. It forms a right angle there. Okay, so again, as you show the work on your blue sheet, you'll write these examples down, and then you'll solve for y and clearly indicate that you are comparing your slopes. In fact, this is even a better way. M equals 3, M equals a -1/3, and then multiplying them 3 times a -1/3 equals a -1. That's the proof that these equations, the lines of which are perpendicular to each other. Now in letter C, as you solve for y, you'll see the equations, the slopes are not the same. One's not the negative reciprocal of the other, so this would be a neither. Now they do intersect, but it's not at right angles. Now if we look at the slope formula in a modified way, and we get this to be linear instead of as a fraction, multiplying both sides by this, we get this formula. This formula is what we call the point slope form, and on our formula reference sheet is number 4. Now it's called that because if we have one point, an x and a y, one point, and we know the slope, from this we can derive an equation. So let's follow example 9. Here our slope is 2, and we have 1 point. And we're going to substitute it into the point slope form. So our slope goes there, and this is our y value, which goes there. And this is our x value, right there, that goes there. And they've done that. So now we multiply through, we get y minus 3 equals 2x minus 2, which is what they have right here. Now we want to solve for y, so y equals, we're just going to transpose that. On this side it becomes a positive 3 minus 2 gives me 2x plus 1. Now here they're just giving us another example. So they're saying our slope is negative 3, so we put that right there. Now our point, our y value is 1, so we put the 1 there. Now our x value is a negative 4. So there's a negative in the formula, so the opposite of a negative makes this value a 4. And again, we solve. Y minus 1 equals a negative 3x and a negative 12. Transpose that to this side, becomes a positive 1, and we end up with y equals a negative 3x minus 11, which is what they have. Now, sometimes they want you to put the equation, instead of slope-intercept, into standard form. For doing that, we would take this term and just transpose it to this side, and it would be 3x plus y equals a negative 11. Just transposing this to the other side. In example 10, they're not giving you the slope, but they give you 2 points. So using these 2 points, we put it in the slope formula, and we find out that our slope is 2/5. Now we take that 2/5 and we can use either of these points. They're using the 5 and the 4. I'm going to use these. So I've substituted my negative 2 here, becomes a positive 2. My negative 10 is a positive 10. Now I have 3 terms. This is one term, and all of this is one term. And an easy way, if you have something with a fraction, is to multiply each term by the lowest common denominator, which is 5. So here the 5's cancel out. So this is 5y plus 10 equals 2x plus 20. Now we're going to transpose the 10 to this side. So this becomes 2x, a minus 10 on this side. So plus 10. And we have 5y. And now we're going to divide both sides by 5. And we get y equals 2/5 x plus 2. Now notice they use the other set of coordinates. It doesn't make a difference which set you use. And the idea, they didn't get rid of the fractions. I like that idea. For those of you who want to stay away from fractions a little, this is the way to do it from an earlier lesson. Now for example 11, we're dealing with vertical lines. Remember, that's formula 6, x equals a. So we just look at our graph, and it's going through a -1. So that is the formula of a vertical line. And what was the slope we said? Undefined. So finally, they're giving us a summary of the various equations. We said this one was formula 6, and we said that is equal to a. And this was formula 5, and that is equal to b. And we said this was formula 2, slope-intercept. This was formula 4, point slope. And this was formula 1, standard form. A good summary. Now for example 12, they're saying razor blades for men can be approximated by this equation. Now notice this is in slope-intercept form, where our y-intercept is this, and this is our slope. Okay? They're giving you sort of an example here. Now x is going to correspond initially to the year 2006. What would be the approximate razor sales in 2011? Well, here we have to remember that 6 is already included in the x. So how many years is this? Well, this is 5 years difference. So our x is, in a sense, 6 plus 5. That's our x now. So that's where we get the 11 from. We multiply this through and we get this, 12.8 billion. So what year would they reach this? Well, here we have to substitute this for our y up here. Let's clear it up. Our y is going to be 10.5, and we have to solve for x. So when we do that, and they are doing it here, we get x is 8. Well, remember, we start off with x is 6 at 2006. So we have to subtract 6 from that. Then we add 2 years to this, and the answer is 2008. We'll see that as we bring it up just a little bit. Right there. So for our last example, we're going to look at a little application. Education, as you read this through, went from this in the year 2000. So we could set that up as an ordered pair. And then in 2011, went to this. We could set that up as an ordered pair. And with that information, we can find our slope, which is this. Now they want an equation for this. So y equals our slope now, which is going to be 453x. And notice that here, if we take away this part, we get a 0 in this, and we get 11 in this. 0 in this is in the form of 0 comma b, which is our y-intercept here. So what we put out there is plus 3768, which is what they're getting down below that we don't see, but we'll see shortly. Okay, you're going to have practice, you're going to have Quizme's, and chapter 2 is short. I believe there's only 3 sections that we cover. So again, we didn't quite finish. There's our basic equation. And now they say, let's see what it's going to be in the fall of 2009. If this projection holds true, we put a 9 where our x is, and we get this. And then how about 2018, looking into the future? Well, where the x is, we put an 18, and this is our value. Okay, we've kept this to just 31 minutes, not too bad.